Welcome to P2. Today we're going to look at recurrence relations, Unit 5.7. Now, this is essentially all about how we get from one term in the sequence to the next term in the sequence. And it's always using that previous term. It's often in this form, un plus 1, and then that's some function of the un, where you'll have like the previous term that you substitute in this side, which gives you the new term, and then that new term gets put into this side, which gives you the new term, and so on. So say for example we had un plus 1, and this equals 3u1 minus 1. Okay? This is our rule, if you like. And then for this to work, we're always told what that first term is. So say that first term is 5. Then we get something like this. So u of, now imagine now n is 1, so it's 1 plus 1, which is u of 2. And that's 3u1 minus 1. So u2 is 3 lots of 5 minus 1, which is 14. Now I substitute that back into the original. So think about it, you get u of 2 plus 1, 3u of 2 minus 1. So u of 3 equals 3 lots of 14 minus 1. And that means that the third term here is 41. So you can see this is my sequence as it's starting, and it will carry on. And that gives you hopefully a bit of an idea of what we do with the recurrence relation. Now that's the general kind of form. Sometimes you might get a u of n plus 2 in here, and this side you'll see a u of n and a u of n plus 1. We'll do an example of that in a moment. But yeah, otherwise it's quite a straightforward idea. And don't forget, sigma notation style questions can also be within this recurrence relation. Okay, so it's just something you need to be aware of. Nice straightforward first example. Find the first 4 terms. So obviously we've already got the first term there. So I'm just going to pop this over here already. Now, finding my next term. Substitute in where n equals 1. So we have 2 lots of u1 plus 3. So it's 2 lots of 7 plus 3. 2 7s are 14 plus 3 is 17. So that's obviously u2 there. I'm just going to pop it in now as u3 rather than the 2 plus 1. So that's 2 times u2 plus 3. So we've got 2 lots of 17 plus 3. 2 17s are 34, so this is 37. We just need one more term, so u4 is 2 lots of u3 plus 3. So that's 2 lots of 37 plus 3. 2 37s are 74 plus 3 is 77. And there we have my first 4 terms. Now, second example, similar, but notice that this time the formula is an n plus 2. Okay, so this is our formula, but we've been given the first and the second term. So we've got the first term is 4, our second term is 6. Yeah, or u to the 1 is 4, u to the 2 is 6. Now, think about it logically. Now, if we've got an n plus 2, so if we put n is 1, that gives me u of 1 plus 2 or u of 3. Now, we've got 3 lots of u of 1 plus 1 minus u of 1. So that is 3u2 minus u1. That's what we've got. So u2 is 6 and u1 is 4. So we get 3 6s are 18, minus 4 is 14. So my third term is 14. To find my fourth term, I've got 3 lots of my third term. I'll put it in like this first. Take away my second term. So it's 3 lots of 14 minus 6. And 3 times 14 is 42 minus 6 is 36. So fourth term here is 36. So just be aware of that. You could have a n plus 2, in which case then you usually got an n and an n plus 1 in this formula, which means you need 2 terms, the first and second term, to be able to use it. So third example here, we've got it in terms of algebra. So our first term is k, and you can see that our formula is 4an plus 5. Now we're actually using a instead of u here, but the process is just the same. So my first term is 1, so to find my second term my first term is k. So this is going to be 4k plus 5, that's going to be my second term. Find my third term is 4 lots of my second term plus 5. So we get 16k plus 20 plus 5, 16k plus 25. So there we have my third term. Now part B wants me to show that this sum is a multiple of 5. Now I've already got the first term, the second term and the third term, so it makes sense just to find out what the fourth term is. The fourth term will be 4 lots of the third term plus 5. 4 lots of 16 are going to be 64. 4 lots of 25 is 100 plus that 5. So we get 64k plus 105. Now, if we think of the sum from 1 to 4 of this, it's going to be k plus 4k plus 5 plus 16k plus 25 plus, I can't quite fit it on the end, but 64k plus 105 should be in there. Okay, so that's each of my terms. So if I add them up in total, I've got 85k plus 135. Now, to show it's a multiple of 5, we just need to take 5 outside. So you just want to think about, right, how many 5s go into 85? And that is 17. And how many 5s go into 135? And that's 27. So now I've factorised out the 5, it's got to be a multiple of 5, because 5 times anything is a multiple of 5. So therefore is, or something along those lines. Just draw it together with some sort of sentence at the end. Now, going with our recurrence relations, we also need to look at a sequence of these types and whether it's increasing, decreasing, or periodic. So simply put, if the next term in the sequence is larger than the previous term, then it's going to be increasing. Okay, sounds very obvious, I guess. You know, if my second term's bigger than my first term, and my third term's bigger than my second term, and so on, it's obviously increasing. Okay, for example, 2, 4, 6, 8, 10, and so on. Now, if obviously we have the opposite in effect, which is that the next term is less than the previous term, then we've got a decreasing sequence. So that could be, I don't know, 12, 6, 0, minus 6, minus 12, minus 18, so on. And these two, I think, are quite obvious. Now, the third type is periodic. And periodic is when we get a type of cycle. So if you get some sort of repeated pattern or cycle, then it's going to be periodic. So an example of this could be minus 3, 2, minus 3, 2, minus 3, 2, and so on. Okay, this is a periodic, and this also has what we call period 2. Okay, because it's two values that are repeating. If I say had, I don't know, 1, 0, minus 1, 0, 1, 0, minus 1, 0, you can see that this one would have period 4, as we're looking at the repeated section. So in this one, you can see that repeated section is 2. In this one, although we do have 2 zeros, they both are part of that one period. Okay, so there is my repeated section, which would carry on, so it's period 4. Think of it like recurring decimals. You know, how many decimal places that keep on recurring, you have that set amount. It's very much the same kind of thing. You look for that repeated pattern, and then the period is how many of them there are that make up that single set that keeps on repeating. Okay, so I put period 2, period 4. I've actually probably missed a word in my haste. Order 2. So period, order 4. Order we do use a lot of in maths. And of course then we could have a sequence that is neither increasing, decreasing, or periodic. Okay, so that could also exist. Now, in terms of an example, if we look at a sequence, say where u1 equals 5, what I do is I start off by writing out the first few terms. It should be obvious, but we've got 5 plus 2, so we got 5 as our first term, then 7, 7 plus 2 is 9, 11, and so on. So it's quite clearly an increasing sequence. We know that this happens for all n, therefore sequence is increasing. Okay, very much the same as if we had a decreasing one, so I won't do a second example for decreasing, but one that's a nice one to show the periodic one is when we look at trig. As if we're thinking of our sine, cos and tan graphs, we know that they repeat. There's a repeated pattern there. So again, if we look at this one, think of the first few values here. So I'm going to start off by putting n equals 1 in. So in this one we would get u of 1 is sine 90, and sine 90 is 1. u2, that would mean then I get sine of 180, which is 0. u3, we get sine 270, which is negative 1. And u4, we get sine 360, which is 0. If I carry on then, u5, that would be sine of 450, and we would get 1. And of course we know that this pattern continues in this way. Now normally I would do a few more values, so find U6, U7 and so on. So I know U6 would be 0, U7 would be -1, U8 would be 0, and so on. I can keep on going here. So this one we could then say, it's periodic and it has order 4. So I'll squeeze it in at the bottom of the video. Periodic with order 4. Now I'm going to pop some questions up. I'm only going to pop one up to do with this increasing, decreasing and periodic. I'll pop that at the end. So I'll put some questions up. I'll try and make some of them challenging a little bit, and as always I'll go through the answers at the end of the video. Don't forget, like, subscribe and share with your friends in school. Help them out as well. If you're finding this useful, they might find it useful. Thank you anyway.